All right, we are going to continue on with the word problems we started yesterday. This is systems of equations. That means we're making more than one equation based on the sentences that they give us in the problem. We stopped at this one yesterday, and there was a reason why. Because these are a little bit different. These are sometimes referred to as coin or mixture problems, where you're mixing together two things of different values. In this case, we're mixing together quarters and nickels. And the fact that a quarter is worth how much? 25 cents, and a nickel is worth 5 cents. That fact is going to become very important in one of the equations. Not in both of them, in one of them. In these kinds of problems, you usually have one equation that's about the number of items. Please stop clicking. In this case, we're talking about the number of coins. It might be a number of tickets. Like lots of times you have different price tickets at the movies for kids and adults. Same kind of situation. Anything with different values. One of the equations is usually about the number of items, the number of tickets, the number of coins, the number of whatever. And the other one is about the value, the money. How much money was made from selling the tickets? How much money does he have in quarters and dimes or whatever you're talking about? The value of the items. Now, on the one that's including the value of the items, then the cost or price or value of each item has to be in that equation. It doesn't have to be in the number of items one. Like, look at this very first sentence here. This has nothing to do with the value of a nickel or a quarter. This is just comparing how many nickels she has to how many quarters she has. What does she have more of? She has more quarters. The number of quarters that she has is specifically 3 times the number of nickels. That's an equation about the actual number of items that she has. It has nothing to do with the value of a quarter or a nickel. What would that equation look like? Q equals 3n. Now ignore that for a minute. Let's get that out of our head. We're not going to try to solve and write the system at the same time. Too many kids are thinking too far ahead. Q equals 3n. That's great. That means we could find some possibilities from that one equation. For example, let's just say she had 1 nickel. If I put a 1 in for my nickel number, how many quarters would she have? 3. If she had 2 nickels, how many quarters would she have? 6. If she had 3 nickels, how many quarters would she have? Do you see what I'm doing here? So these are some possibilities, but there's millions of possibilities. I need another fact. And once I get another fact, I'm going to have a system of equations that I'm going to solve, and I'll figure out exactly how many of each she has. Now here comes the tricky part. She has $1.60 in all, made up of quarters and nickels. And this is the thing that kids do wrong all the time on this. Q plus N equals $1.60. And that is not right. Yes. It's 25 cents times every quarter plus 5 cents times every nickel equals $1.60. It's not just Q plus N equals $1.60. It's 25 cents times every quarter, because what is this going to tell us? If you take how many quarters she has and multiply it by 25 cents, what does that tell us? How much money she has in quarters. That's her quarter money. Plus 0.05 times N. If I take the number of nickels she has times 5 cents, that gives me her nickel money. And all of that money added together equals what? 160. And if you leave out the 25 cents or the 5 cents, it's not going to work. So it's kind of an extra piece that you have to know to insert into the equation that's about the value of the money or the tickets or the whatever you're talking about. Okay, now there's some things we can do to make these equations nicer. Or at least the bottom equation can be nicer. The top one's pretty nice already. I would probably do substitution on this. I like addition, usually the addition-elimination method, but this is absolutely set up for substitution. If Q equals the same thing as 3n, wherever I see a Q, what could I put? 3n. But before I do that, I want to talk about the bottom equation, because this is what I will usually do. You don't have to do this if you don't want to, but I like to work with whole numbers if I can. So I chose to multiply the whole equation by 100. Multiplying by 100 moves your decimal how many times? 2 times. That would give me 25Q plus 5N equals 160. Do you see what I did there? That's a perfectly legal thing to do to an equation as long as you do the whole thing, you do the same thing to every number on both sides of the equation. Basically what I did is I multiplied by 100. Do I have to do that? No, but to me it makes it much easier. Now I'm ready to solve. So I adjusted my coin equation, And I looked at the problem and asked myself, what's the easiest way? And I think substitution is going to be the easiest way. Since q and 3n are the same value, what can I put in place of this q right here? 3n. That's what I'm going to do. I'm going to put a 3n there in place of the q. So instead of 25 q's, I have 25 3n's plus 5n equals 160. See what I did there? Now I have only n's. You have to have an equation with just one letter. What's 25 times 3n? 75n plus 5n equals 160. 80n equals 160. What's the nickel number? 2. So I know now that she has 2 nickels. I still have to figure out her quarter number. I would use this equation. Super easy. Use this one. 6. She has 3 times as many quarters as nickels, so that would give her 6 quarters. That should be my correct answer. First of all, does she have 3 times as many quarters as nickels? Yes. Second of all, let's make sure she's got $1.60. How much is 2 nickels? 10 cents. How much is 6 quarters? $1.50, right? Does she have $1.60 in all? Yes. So it had to be 2 nickels, 6 quarters. Okay, let's go back. Q equals 3n was our first equation. Then my modified version of the next equation was 25q plus 5n equals 160. I said that we could do substitution easily. Guess what? We could also do the addition method easily. If you are kind of kid who wants to stick to one method no matter what, then we could do that too. The 3n would have to come over here to this side, and what happens to it when I do that? It becomes what? Minus 3n. And what's left over here when I do that? 0. So even though it was set up nicely for substitution, if you prefer the addition method, you could do it that way too. I would probably multiply the bottom equation by negative 25 to make the quarters cancel. See what I'm doing there? That would give me negative 25q plus 75n equals 0. Negative 25 times 0 is still 0. And now when I add up that top red one and this bottom blue equation, I'm going to get 80n equals 160. And I still get my answer of 2 nickels, and then I can work up and figure out there were 6 quarters. So either method works anytime. To me, most of the time I use the addition method, but when it's this obviously set up to do substitution, sometimes I'll just do substitution. All right, let's try another one. Let's practice writing these equations. You try this one. Try to write the equations for this one, please. That very first sentence alone is enough to make an equation. Paul has 30 coins in dimes and quarters. Does that have anything to do with how much money he's got? No, it's just counting his coins. If you actually counted his coins, there'd be a total of 30 of them. Made up of what? Dimes and quarters. So what equation would that look like? D plus Q equals 30. He has 30 dimes and quarters. That has nothing to do with how much money. That had never said how much money he had in that equation. It just said he has 30 coins. He has 30 things in front of him. Now, the next equation is about how much money he's got. He's got $4.50, and these items are different values. So you cannot just say D plus Q equals 450. That's not going to work. You would have to say what? 0.10 D plus 0.25 Q, because that's his dime money. 10 cents times every dime and 25 cents times every quarter would equal the money he's got. The $4.50 he's got. And again, you don't have to, but it'd be super easy to multiply this whole equation by 100 and make them all nice whole numbers. 10D plus 25Q equals 450. I'm going to erase that middle one. To me, this is set up really nicely for the elimination, the addition method. I'd have to rig it a little bit. What would I have to do? Multiply by negative 10 or negative 25, depending on what you want to make cancel. I think negative 10 would probably be easier. That would give me negative 10D minus 10Q equals negative 300. Now when I add them up, the dimes will cancel. And I'm going to get what? 15Q equals 150. So what would Q equal? 10. Now I'm not quite done. I want to know how many coins of each type he has. I just found the quarters. In the beginning, they told us he had 30 total coins. So if 10 of them are quarters, 20 of them must be dimes, right? That gives me 30 coins. Let's make sure the money works. How much is 10 quarters? 250. How much is 20 dimes? $2. So how much money does that give him? 450, which is exactly what it said he had. Okay, so let that sink in for a minute. One equation is usually about the number of items. That has nothing to do with value. The money equation does have to do with the value of each different type of item. And it's not always coins. It could be anything with different prices. These seem easier? Good. All right, let's see what you think about this one. Read this one. You spoke too soon. Okay, so now we're not talking about different priced coins. Now we're talking about different priced tickets. So I'm just going to write up to the side. Adult tickets are what? $2. Just to make a note for myself. Student tickets are $1.50. That is going to make a difference in one of my equations. Not in both of them, but in one of them. What number do you think is going to be affected in the equation that has to deal with the $2 and the $1.50? What other number in the problem? The 550. Because that's how much money they made from those two different items coming together. Those two differently priced items coming together had a total value of $550. So what would that look like? $2 times every adult ticket plus $1.50. I just usually put 1.5 for $1.50. $1.50 times S equals 550. That's the one about the money. The total money earned has to include the cost of each differently priced item. It has to. Now, the next equation has nothing to do with money. It's just somehow relating the number of adult tickets to student tickets. Sometimes in a nice, clear way, sometimes in a very convoluted way. So just do whatever it says. The number of adult tickets was, which is the same thing as is or equals, adult tickets is 100 less than 3 times students. A is 3s minus 100. There's my two equations. Adult tickets is 100 less than 3 times student tickets. That has nothing to do with the value of the items. Now, you might be a substitution person. You might be an elimination person. We can do it either way. And on one like this, it's kind of a toss-up for me. Usually I tend to go towards the elimination method. But it is set up for substitution. Do you see why? Do you see how A and 3s minus 100 are interchangeable? If you have one letter all by itself, then you're considered substitution ready. Wherever I see an A, what can I put in its place? So do you see this A right here? What can I put in its place? 3s minus 100. Now my top equation only has s's in it. You have to get rid of one of the letters in order to solve this. You got to solve them one at a time. But be careful, that 3s minus 100 has to get multiplied by 2. So I'm going to rewrite that new equation down here. That's going to give me 6s minus 200 plus 1.5s equals 550. And now this equation has nothing but students in it now. 6s plus 1.5s, that's 7.5s, right? What do I do with that minus 200? Add 200 to both sides, and you're going to get 7.5s equals 750. What's $750 divided by $7.50? So guess how many student tickets then? 100. I try to make my s's fancy so they don't look like 5s. 100 student tickets. Now, I still have to find the adults. So I would go back to that bottom red equation. Adults equals 3 times s minus 100. What did we just figure out s was? So adults would equal 3 times 100 minus 100. 300 minus 100 is 200. And there's my answers right there. Exactly. They want to make it complicated. Okay, now, fear not, you people who love elimination. If you are not a substitution person, let's do this again with the elimination method. For the elimination method to work, you've got to have, it's kind of got to be in standard form with your adults and your students lined up. So look at the bottom equation. What am I going to have to do there? Exactly. I'm going to have to make that a minus 3s equals negative 100. I just have to adjust this a little bit. I'm going to rewrite the top equation underneath it. 2a plus 1.5s equals 550. It does not take much to do this with elimination either. I can multiply the whole top equation by negative 2 and cancel out the a's. That's going to give me negative 2a plus 6s equals positive 200. And I'm going to get that same equation I got a second ago. 7.5s equals 750. And I'll get the same answer I got a second ago. Students equals 100. And then adults, go back to this equation again. Adults is still going to come out to be 200. So it doesn't matter which method you like the most. Pick one you like the most and just make it work. Okay, let's try. You try this one on your own. Now, they put all the information that you need into the second sentence, but you kind of got to pull it apart into two separate equations. Well, I guess they told us what kind of coins in the first sentence. We got dimes and quarters. And the second sentence told us there's 28 of them, and they come up to $4.60 when you add up all the money. So who can give me the number of coin equations? Yes. Absolutely. I just usually do it this way. D plus Q equals 28. There's 28 coins. That has nothing to do with money. There are 28 coins, dimes and quarters, adding up to 28 coins. Who can give me the money equation? Go ahead. Plus 0.10D plus 0.25Q equals $4.60. Now, I just went ahead and I moved the decimals all over at the same time that I wrote the equation, if that's okay with you guys. Do you have to do that? No, I just prefer whole numbers. Now, be careful with nickels, though, because guess what kids sometimes write for nickels? 0.5, and then they end up changing it to 50 cents. A nickel is 0.05, so be careful with the nickels. Now, see how nice and easy this is, ready to go for the elimination method if you rig it a little bit. How could I rig it? Multiply by negative 10 to make the dimes cancel, or multiply by negative 25 to make the quarters cancel. I agree, negative 10 is probably going to be easier. That would give me negative 10D minus 10Q equals negative 280. And now when I add up my two equations, the dimes cancel right out. I'm getting 15Q equals 180. And use your calculator. What's 180 divided by 15? Now, there were 28 coins. We just figured out 12 of them were quarters, so how many of them would have to be dimes if there's 28 coins? 16. Because 28 minus 12 is 16. Let's make sure it works. 12 quarters. Remember, every 4 quarters is $1, so how much is 12 quarters? $3. How much is 16 dimes? $1.60. Does he have the right amount of money that he was supposed to have? Yes, he does. $4.60. Oh, how many quarters? Good point. How many quarters does he have? It didn't ask for dimes, did it? The answer to this question was really just 12. Good eye, Benny. You're the first person that caught that today. Now, I probably still would have gone ahead and figured out the dimes because I like to make sure my money is correct. I would suggest you make sure your money works. Okay, next. Now, this one's a little different, folks. Look up here. Read this because remember, I've said before I hate to use the words always and never in math because then they'll find an exception. Usually, if you're dealing with money, you have to include the value of each item in there. But the problem with this question is we don't know the value of each item. That's what we're trying to find. We know two different people's purchases at the same pet store. They bought two of the same types of items, and it had two total different amounts that they owed the cashier. We're going to use those two facts to make an equation for Rhonda, an equation for Kelly, and we're going to actually solve for the price. We don't know the price. We know how many they bought this time. We don't know how much it costs. Who can tell me Rhonda's equation? 3D plus 4B. Exactly. That's Rhonda's equation. She bought 3 dog bowls and 4 bones, and her total price was $11.50. What would Kelly's equation be? Boys, 2D plus 8B equals $13. Okay, so this is a different situation. Now you're going to get a decimal answer for one of these because guess what we're solving for? We're finding the cost. It's not going to be one of them's not a nice whole number, but that's no big deal. You've got calculators to help you with the equations. How can we make something cancel though? There's more than one way. There's lots of things we could do. Multiply the top by -2. What would that accomplish for us? It would cancel out the bones. I would multiply the top by -2. That's going to give us -6D minus 8B equals -23. And then the bones would cancel. I'd have -4D equals -23 and 13 is -10. And this is the one that's not a nice whole number. Use your calculator. What's -10 divided by -4? So how much do the dog bowls cost then? $2.50. Each bowl is $2.50. What do I still have to find? Okay, so go back to one of the equations. I think that middle blue equation would probably be the easiest. And I'm going to put in $2.50 for the price of the dog bowl right here, $2.50. What's 2 times $2.50? 5. So this equation, I'm going to write it up here, would now say 5 plus 8B equals 13. Subtract 5 from both sides, you get 8B equals 8. How much is a bone? Just $1. So we found the price of the bone, we found the price of the dog bowl by using two different people's purchases. These questions are old. Yes, there will be these questions on your mock star, absolutely. Yes. Okay, now, this is the actual question that was on the end of course exam a few years ago. They like to pick strange situations. It's not about money, it's not about cost of items, it's not about tickets. It's about how high a stack of library books is. Okay? Now read this and see if you can decipher how we're going to pull this apart into two different equations. And when you are doing this problem, I would jot down some notes. There are two different types of books. Some of them are 2 inches high and some of them are 3 inches high. And they tell you specifically what to call them. What do they tell you to call the 2-inch ones? Okay, so I'm going to write that down to the side. And the Y's are the ones that are 3 inches high. Keep that in mind. Now, the question, I don't know if you noticed, says just to write a system, and sometimes that's all they ask you to do. Write the system that would solve the problem. Now, we're going to write it, and I'm also going to have you solve it. But let's focus on writing it first. The very first sentence is its own equation. There are 12 books. 12 total books made up of different types of books. X plus Y equals 12. That has nothing to do with how high the stack is. That's just we've got 12 total books, and they're two different types. Now, what's the total height of the stack? 31 inches. In that problem, in this piece of information, it does matter that the X ones are only 2 inches high and the Y ones are 3 inches high. So what would that look like? 2x plus 3y equals 31. That would be the equation about height. That's like our version of the money. That's the height equation. It'd be super easy to solve this, even if you were just asked to write it. Multiply the top equation by -2. Negative 2x minus 2y equals negative 24. You see what I did there? I multiply the top equation by -2 so that the x's would cancel. Then I get y equals 7. Well, there was 12 books, so the rest of them have to be the other x's, which would be what? 5. Now let's make sure that that works out height-wise. If there were 5 of these, that would be a total of 10, and if there were 7 of these, that would be a total of 21. Does that work out? Yes. Okay, now, only one more thing that we're going to do, because sometimes in a problem, a tricky phrase will come up, and I was going to save all of this for tomorrow, but there's one question. Guys, I'm trying to help you. There's one question that has a similar phrase or sentence in it to this problem right here. Now, this by itself is not its own question. This is just a phrase. We're going to make an equation out of this phrase, but it's not. We don't have enough information to do anything with it. You're going to have a question number 3 on your homework is going to have a very similar phrase to this. This is tricky, and it's still tricky to me. The way this is worded, it's hard to make an equation out of it. So this is what I do when I see a question like, or a phrase like this. What does he have more of? He has more quarters. Can you understand from the sentence it's saying he has more quarters? Okay, so I ask myself, what does he have more of? And I make sure my equation makes it to where he has more of those. That means you'd have to take his dime number and add 9 more to it just to equal up to his quarter number. Wouldn't that give him more quarters? Yeah, specifically 9 more, which is what it told us. Now, the phrase that you have, we'll just go ahead and do it together. On number 3, there's a phrase or a sentence in number 3 that says Bob has 6 more dimes than quarters. And you're supposed to make an equation out of that. And it's not about the value of the money, it's just about the number of dimes compared to the number of quarters. What does Bob have more of? Okay, what does he have more of? Dimes. So D equals Q plus 6. You got to make sure you work it out to where he's got more dimes. He has 6 more dimes than he does quarters. This would give him more dimes right here. Okay, we're going to practice some more with the trickier phrases tomorrow. Your homework, which you're going to start right now so I can help you with things like that come up like number 3. I didn't realize that till 3rd period that there was a tricky phrase in number 3. Your homework is page 350, 1 through 10.